Okay, this is going to be the Algebra 2 sample test for Chapter 4 on radicals for 2014, 2015. I'm going to go through this. You should have a sample test. When we get to the section on properties and number sets, I'm just going to tell you to pause the video. I'm not going to go through that, but all the information will be written. Okay. One thing you want to do with all your radicals, okay, is you always want to type into the calculator the numbers first. Because what we want to avoid is we want to avoid making dramatic mistakes here. So, so for this one, that's the cube root of negative 162 divided by 3. So I'm going to do cube root of negative 162 divided by 3. Okay? And now, I'm going to, all right, that's negative 3.77. All right? And as you can see, all right, I can't turn that into fraction or decimal, so I'm going to have to reduce it. But when I get done, I want to compare my results. So I'm going to handle the numbers first. I'm going to divide negative 162 by 3, okay? And I get negative 54, so I got the cube root of negative 54, okay? So when I break that down, that's 2 and 27, 3 and 9, 3 and 3. Since it's a cube root, I'm looking for groups of 3, okay? Looking for groups of 3. So what I'm going to have is on the outside, because it's negative, I'm going to have negative 3, cube root, okay? All right, I can't use the 54, the 27, or the 9. The 2's got to go inside there. All right, to handle the numbers, the variables, what I'm going to do is I'm going to subtract these two. So that's going to be the cube root of x to the 8th, okay? The cube root of x to the 8th. Now, what you can do there is you're going to divide 8 by 3. And what would happen is that would be 2 with a remainder. All right, here's how you figure out the remainder. 3 times 2 is 6. How many more to get to that? That's 2. Okay? So basically, what's going to happen here is that's going to be x to the squared on the outside, x squared on the inside. So here's my final answer. Now, let's go back and check to make sure I did it right. How could I do that? Negative 3 cube root of 2. Okay? So I'm going to type that in, and did I get negative 377? Good. So I know that the number answer is correct there to a certain extent. Okay? Let's come down here to number 2. All right, 192. What I'm going to do is I'm going to take the fourth root. Now here's how you take the fourth root. There is a little x to the square root there, so I'm going to do 4 shift and this button right here. Okay, and I'm going to type in 192. All right, I get 372. Okay, so I'm going to make note of myself. 372. Okay. So I'm going to break this down. That's going to be 2 and 96. All right. I can divide that by 2. It's 2 and 48. I divide 48 by 2. That's 2 and 24. 24 by 2, 2 and 12. 12 by 2, 2 and 6. 6 by 2 and 3. Okay. All right. So I'm going to cross off everything here. Okay. All right. Since it's fourth root, I'm looking for groups of 4. So there's a group of 4. These all are leftovers. So I'm going to have 1, 2 on the outside. Okay, I'm going to have 2 times 3 on the inside, which would give me 2 root, that's going to be 12. Okay, now how do I make sure I'm right there? All right, am I right with my number? Okay, 2, all right, times, okay, 4 root 12. And I can see, all right, that is the same answer. So numerically, I'm good. Okay. How do I figure out the variables? Okay. 2 divided by 4. Can 4 ever go into 2? No. So that's just going to stay all inside. Okay. It's going to stay all inside. 4 divided by 4. That's easy. That's going to be 1. Okay. So that's y to the first on the outside. Okay. 7 divided by 4. That's going to be 1 with the remainder of 3, because 1 times 4 is 4. 3 more gets you there. So x to the first outside, z cubed on the inside. So that's my answer. Okay? All right? That's my answer. All right? Moving on to this one. All right? 6th root. Okay? 6th root. So how are we going to do that? Well, we're going to type 6 shift 64. And it tells me I'm 2 now, so that saves me a lot of time right there. All right, I don't need to do all the factor tree stuff. Now I'm going to take 6 and I'm going to divide by 6. Okay, so that's going to be 1. So that's going to be x to the first on the outside. I'm going to do y13 divided by 6. Okay, All right, 13 goes into 6 twice. Okay, that'll give me 12. One more would be the remainder. Okay, so let me move this down a little bit. All right, so what I'm going to have is 2x to the first. All right, I'm going to leave some space there. All right, y 2 on the outside, y 1 on the inside. I'm going to take z3, 3 divided by 6. Okay, so basically what I'm doing each time is I'm taking the exponent divided by whatever the root is. Now that doesn't go into there, so z3 is going to stay all right there, and that's going to be my answer for that one. Okay, moving down here to this one. Okay, what you can do, it's very similar. Okay, all right, very similar. So I'm going to take the square root of 125 divided by the square root of 5. And I get 5 for my answer. So, boom, that saves me so much work. Okay? All right, now, what I got to do is I got a 1 there, so what I'm going to do is subtract those. So I got the square root of x to the 6th that I have to reduce. Well, since it's 6, 6 divided by 2 is 3. So that's just going to be x to the 3rd. Okay? That's the way you do that one. All right? So always check those numbers, because you might be able to do stuff a lot more quickly. Okay, moving on here to number 5. All right, moving on here to number 5. So what I'm going to do is I'm going to deal with the numbers first. So 4, all right, root of 12 times 5 times 4, okay, root of 27. Okay, so I got 21.2. So when I get done, I'm going to check to make sure I got 21.2. Now the way this works is this is a 1 out here, so 5 times that would be 5. Okay, got a little 4th root deal going on there. Okay, 12 times 27. 12 times 27 gives me 324. Okay, I'm also going to add these, which would give me x to the 7th. Okay, all right, so when I'm figuring this out, I already know 5 is going to be involved in my answer. Now, when I break down 324, I'm going to run out of room here real quickly. So I'm going to work down through here, and then I'm going to erase it. All right, so I got 2, and I want to say 1. 324 divided by 2 is 162. Okay, 162 is 2 and 81. All right, 81 doesn't get divisible by 2, but it is divisible by 3. So keep going up as you go. All right, 3 and 27, then 3 and 9, and 3 and 3. Okay, so I can cross off everything that has a number from it. Okay, and since it's the 4th root, I'm looking for groups of 4. So here's a group of 4. All right, both of these are leftovers, so I put one of those there. Okay, I've got 2 and 2 that's going to be on the inside. Okay, so from a numerical standpoint, I'm at 15 4th root of 4. Okay, now let's check to see if I'm right there. 15 times the 4th root, 4th root of 4. And I got 21.2, so my number part's right. Now for 7, since it's a 4th root, it's going to be 7 divided by 4. Well, that's going to go in 1 time. All right, that times that would be 4, so I need 3 more, would be the remainder. Okay, so that's going to be x to the 1st on the outside, x to the 3rd on the inside. So that's going to be my answer there. Okay, all right, moving back up to these problems up here. Okay, I'm probably going to erase some of this stuff. All right, now what you got to look at here is what reduces out of this. Okay, so let's look at our number. Let's do 6 square root of 4. Okay, that's 12. All right, well, I've got 12 there. All right, okay, we'll get to the variable in a second. All right, let's do some of the other numbers. 4 square root of 4 is 8. Okay, got 8 there. And then I got 2 square root of 3. Okay, that's 3.46. Okay, now, so what I got here, let's deal with the variables. So with that, x squared 2 divided by 3 would just be square root of x squared minus. Okay, once again, this is going to be same x squared divided by 2, so that's x squared. Okay, plus, all right, and all these are cube roots. Okay, plus that one's not going to be able to reduce. Okay, because 3 doesn't do anything and x is not going to do anything. So the only things that are going to combine here are these two. So 12 minus 8 is going to be 4 cube root of x squared plus 2 cube root of 3x. Okay? All right, now, I'm going to go on to this one. I'm going to go ahead and erase this. Okay, I'm going to go ahead and erase this. All right, because I need some room to work. All right, so I'm going to make sure I got 3 square root of 128. All right, I got 33.9. All right, I want to make sure when I reduce I got that. Let's say 4 minus the square root of 108. Or actually, you know what I can do? Let's stop that for a second. Let me just type all these in on one line together. 3 square root of 128 minus 4 square root of 108 minus 5 square root of 162. Okay, so I got negative 71.26. So when I get done, that's what I want my answer to be. Okay, now because there's a 3 in there, let's branch this off. I know I'm going to have 3 involved in the answer somehow. Okay, 2 and 64. Okay, 2 and 32. All right, 2 and 16. Okay, 2 and 8. 2 and 4. Okay. All right. So what happens here? I'm looking for pairs. So that's 1 pair, 2 pairs, 3 pairs. Okay. The leftover is going to be 2, which will be inside. I take 1 out of each of these. So times 2, times 2, times 2. Now what that's ended up going to be, and that's 2 times 2, which is 4. Times 2 is 8. All right, I use the calculator if you need to see that. 2 times 2, okay, times 2 times 3 is 24. So this is going to end up being 24 square root 2, okay? And then for work's sake, I'm running out of space, so I'm going to erase that, okay? So if you need to pause it, go ahead and do that, but I'm going to go ahead and erase that. So that's that part, okay? All right, when I break down this, I know I'm going to have a 4 involved in this answer. All right, I got 2 and 54, 2 and 27. 27 is not divisible by 2, but it's by 3, then 3 and 3. Okay, once again, I'm looking for squareds. I'm looking for pairs there. So here's a pair, that's a leftover. All right, so I got 2 there, I got 3, and I'm going to have square root of 3 on the inside. So 3 times 2 times that's going to be 24 square root of 3. Okay. Once again, that's how you would reduce that becomes that. So take a look at that. Now I'm going to go ahead and erase it. Okay. We're going to go ahead and do the last one, right? That's square root of 3 there. Okay. So once again, 5 is going to be involved in the answer. All right. 2 and 81. Okay. All right. That's going to be 3 and 27. 3 and 9, 3 and 3. All right, once again, pairs, 1 pair, 2 pair. Can't use these, okay? So what's going to be, I'm going to take one of those 3s, one of those 3s, and what's going to be left over is my 2 on the inside. So that times that is going to be 45 square root of 2, okay? So I'm going to go ahead and erase that. All right, so what I got here is minus 45 square root of 2. So I'm going to keep all of those together, okay? All right, I'm going to keep all those together. Now, the only ones that can combine there are this one and this one, okay? And all I do is 24 minus 45, I get negative 21. So I got negative 21 square root of 2 minus 24 square root of 3. Now, let's go back to my answer, 21 square root of 2 minus 24 square root of 3. And look, that matches up with what I got originally, so I know I'm good. Okay? All right? Okay? Now, for this one, what I want to do is I want to set up a box. Okay? I want to set up a box where I got 2 square root of 3, square root of 5, 3 square root of 6, negative 4. Okay? When I multiply these, I'm multiplying the outsides and the insides. So I got 6 square root of 18. Okay? I've got 3 square root of 30. I've got negative 8. When I do this one, that's going to be negative 8 square root of 3. So you can only multiply the outside numbers. Okay? Then I got negative 4 square root of 5. Okay? Now, what's nice is these two are reduced here. Okay? These two, all right, I'm going to have to simplify. So I'm going to simplify 8 square root of 18. Okay? I'm going to simplify 8 square root of 18. So what I'm going to have are 6 square root of 18. So that's 2 and 9, 3 and 3. There's my pair. That part's going to go on the inside, so that's going to be 18 square root of 2. Okay? All right? So I got 18 square root of 2. To simplify that one, I got 3 square root of 30. That's 2 and 15. Okay. All right. 3 and 5. Okay. All right. 3 and 5. 2, 15, 3 and 5. There are no pairs, so I'm left with that. Okay. So this is going to be 18 square root of 2. All right. It's going to be 18 square root of 2. Okay. So if I draw a new box, these were the results. Okay, 3 square root of 30. Okay, negative 4 square root of 5. Nothing combines here. So I got 18 square root of 2 plus 3 square root of 30 minus 8 square root of 3 minus 4 square root of 5. Okay, so you just have to have those reduced. Now, could I check to see if I was correct there? Okay, sure. All right. So what I want to do is 18. Let's go back and do my original. All right. I got 2 square root of 3 plus square root of 5 times, all right, 3 square root of 6, whoops, 3 square root of 6 minus 4, okay? And I get 19.08. Well, what's my final answer? 18 square root of 2 plus 3 square root of 30, all right, minus 8 square root of 3, all right, minus 4 square root of 5. And if you notice, same thing. That's how I know I'm right, okay? Now on this one, all right, what you want to do is multiply that, so that'd be a 3 square root of 2 plus 4 square root of 20, okay? All right, that's not going to get any smaller, but 20 can. So it's 2 and 10, 2 and 5. There's my pair. So I got 4 times 2 times the square root of 5. Okay, this is going to be 3 square root of 2. So what that's going to be is 3 square root of 2 plus 8 square root of 5, which I will not be able to add those or combine those anymore, okay? Because, all right, those radicals are not the same on the inside. Once again, how do I check my answer? Am I right? Square root of 2, all right? Parentheses, 3 plus 4, square root of 10. Okay, I got that for an answer. 3 square root of 2 plus 8 square root of 5. Same thing, all right? So that should help you right there, okay? And the last one, the cube ones, okay? The cube ones, all right? So I'm going to handle all these individually over here. So I got 6 cube root of 16, okay? All right, I'm going to go ahead and type all this in to start as well. 6 cube root, 6 cube root of 16 minus 4 cube root of 32 plus 2 cube root of 54. And I just want to make note that that's 9.97, okay? 9.97. So when I break these down, that's what I should get when it's all said and done. All right, 2 and 8, 2 and 4, 2 and 2. All right, here's my triple. Can't use these, okay? So what I'm going to have is 6 times one of these 2's with a cube root of 2, because that's a leftover on the inside. So that's going to be 12 cube root of 2, okay? All right, in interest of space, that's what that's going to be. Go ahead and pause it if you need to get that. All right, now I'm going to go break down the next one. Okay? All right. So as you do these, what I would try to do is make sure that you have, whoops, I think I typed it in wrong. Hold on. Is that a 4? Yeah, that's a 4. I'm sorry, we shouldn't have had that for an answer. That's 6 cube root of 16 minus 4 times the 4th root, okay, of 32 plus 2 times the cube root of 54. Okay, that's what we should have when we get done. Okay, so I got 4th root of 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay, so I'm going to have the 4 involved, one of these 2's, and then the leftover 2's going on the inside. So I got minus 8, 4th root of 2. Okay, once again, I'm going to erase that, all right, for room's sake. Okay, all right, so let's go to this last one. 2 cube root of 54, 2 2 and 27, 3 and 9, 3 and 3. There's my triple. Okay, so what I'm going to have there is I got that 2 on the outside, I got that 3, and I got this 2 as a leftover. So that's going to be 6 cube root of 2, okay? Once again, so that's going to be 6 cube root of 2, okay? For space sake, go ahead and take a look at that. If you need to pause it, pause it. All right, I'm going to go ahead and erase it. Okay, so I got plus 6 cube root of 2. All right, now that we're at that point, I know that was a lot of work there. What I want to do is combine, the only ones I can combine are this one and this one, because same number inside, same root. You can't combine this one because it's got a 4 there. So 12 plus 6 is 18. So 18 cube root of 2 minus 8 fourth root of 2. Okay? Now let's see if we were right. 18 cube root of 2 minus 8 times the fourth root of 2. And it's the same answer, so we're good there. Okay? Let me go ahead and erase this. Okay, now, this is where a lot of people get tripped up. Write the expression in simplest radical form. Okay? So, here's the key word. Radical. That means it's got to have something like that when you get done. Okay? Now, with these, what you're going to want to do is you're going to want to add the exponents. Okay, so that's an x and an x. So I want to add 1/5 plus 2/5. And I get 3/5. So x to the 3/5. Now, what does that mean? This is the exponent. This is the root. Okay? All right? Now, we treat this almost like we did back here. Like these were the exponents, and those were the roots. All right? So it's not much different. So can 5 go into 3? No. So that means the whole thing is going to stay on the inside, and the root's going to be that. Okay? All right? Now, all right, on this one, I can't combine anything there. All right? So let's look at this. 7 square root of 2. So 7's here. Okay? Now, 2 go into 5. All right? So let's break down that. That would be 2 with the remainder of, well, that would be 4. 1 more would be 5. All right, so let me move this rooming. The room's a big issue on this sample test. All right, so it's going to be 1. All right, so what I got is I got square root of 7. All right, 2 on the outside, 1 on the inside. Okay, once again, for 3 and 2, that's going to be 1, and the remainder is going to be 1. So that's going to be y to the first on the outside, y to the first on the inside. So look at my answer. It's got a radical with it, okay? Now, let's take a look at this one. This is going to be negative 27 to the 1/3 x, all right? Now, what should we do with these? You should multiply those. So I got negative 9 times 1/3, okay? Which is negative 3, all right? Now, let's type this into the calculator. Negative 27 to the 1 divided by 3. If you notice, all right, oh, oops, I did that wrong. Negative 27 exponent to the 1/3. Okay, I get negative 3 as my answer here. This is x to the negative 3. What negative exponents tell us to do is put them underneath. So that's actually my final answer. Okay, this one, as you can see, you don't have like denominators. So what you're going to have to do is make them into like denominators. Well, the simple way to do that, if you got 1/3 and 2/7, is just multiply them by each other. Okay? So this one I have to multiply by 7, top and bottom. This one I have to multiply by 3, top and bottom. So what I got is I got x to the 7 over 21, y to the 6 over 21. Now, same deal. Could 21 go into 7? No. Could 21? No. So what you're going to have is 21's the root, x7, y6. There's your answer. Okay? All right, moving on. All right. Now, write as a rational exponent. So what that means is you should have an exponent answer. These radicals should be gone. So what this is x7 over 3. Now, what you should try to do is, can 7 divided by 3 reduce. No, it stays 7 over 3. I'm done. Okay? When you go to this one, there is a 1 here for the 3. So that's 3 to the first. That's a square root squared. I got x to the 4th over 2. Y's got a 1. All right? So what I'm going to try to do is see if any of those reduce. Okay? 1 divided by 2. All right? Still 1/2. 4 divided by 2. That's 2. So what I'm going to have is 3 to the 1/2, x squared, and then the 1/2 over here is going to stay as well. So here's my final answer. As you noticed, I have exponents. That's why it says exponents. Same thing here. 5 to the 1/8, x to the 1/8, 10 to the, or y to the 10/8, z to the 4/8. So let's go ahead, well the 1 divided by 8, that's going to stay the same. 1/8, 1/8, okay? To do the other one, 10 divided by 8, 5/4, 4 divided by 8, 1/2. So 5/4, so y to the 5/4, z to the 1/2 power, okay? This one, so what this is saying is basically 5th root of 9 cubed x cubed, okay? So what I'm going to get there is 9 to the 3/5, x to the 3/5. And I don't think those are going to reduce, but you can check, okay? All right, 3/5 for the fractions, 3 divided by 5 is going to stay 3/5. So here's the answer. So the point is, where some people get confused on these, is when it says rational exponents, you end with exponents. When you have the ones that say, okay, when you have the ones that say radical form, you got to end in radical form. As you can see, those all end with radicals, okay? All right, or no exponents, all right, if you will. Okay, here are the answers for these, so go ahead and hit pause and take a look at those. Okay, going on to the next, here's what this picture looks like. Go ahead and hit pause. Take a look at that. Okay, going on to the other property questions. Okay, there's the answers for those. Go ahead and hit pause, see your teacher for clarification. Okay. There's the answer for those questions. Go ahead and hit pause. Okay. And there's the answer for the last one. Go ahead and hit pause. See your teacher for clarification for corrections or any questions you have. Okay. Write 36 in A plus BI form. Okay. All right. So square root of 36 is 6. Okay, so you can write that as 6 plus 0i or just 6. Okay, complex numbers have 2 parts, a real part, imaginary part. Okay, here we go with this. All right, square root of negative 49. Now, to set your calculator for negative square roots, option, setup. Whoops, let me get to the run screen. I'm sorry. Let me clear this. Option, setup. Okay, I'm sorry, shift option, complex, okay, all right, square root of negative 49, okay, oops, I think I got a menu, system, okay, hold on, let me go back to that other screen. All right, let me get my calculator set, and I'm going to tag this video together.